Amid the boundless expanse of the cosmos, where icy wanderers and ancient worlds silently drift, an unexpected visitor has swept into our solar system, shocking astronomers, breaking all conventions, and rewriting the narrative of cosmic discovery. Imagine, for a moment, a vibrant streak racing across our star's domain at a speed that's nearly double that of any previous interstellar guest. This is no ordinary celestial spectacle. This is the story of Interstellar Comet 3I/Atlas, and it is one that has left even the most seasoned observers standing in awe at the peculiarities encoded in its light. On a quiet night in early July 2025, telescopes around the world first caught sight of this enigmatic traveler. 3I/Atlas was hurtling through the solar system, its origins tethered not to our own sun, but to the deep, frigid darkness between the stars. Initial calculations hinted at the scale: a rocky nucleus roughly 5.6 kilometers in width, carrying a mass of over 33 billion tons. Its sheer momentum alone was enough to draw gasps from astronomers. But as the days unfolded and the comet arced ever closer to our sun, it began to share secrets that have defied everything we thought we knew about the frozen messengers of space. A team of researchers, their curiosity piqued, began an intensive study of 3I/Atlas's light. They trained their sensitive instruments not just on its brightness, but on the subtle orientation of the light waves bursting forth from its dusty veil. What they discovered would soon ripple through the scientific community. The light from 3I/Atlas was misbehaving, defying categories and confounding expectations. In their newly published findings, submitted to the Astrophysical Journal Letters, the team announced that the comet exhibited an extremely deep and narrow negative polarization branch, a technical phrase that, in simple terms, means its light reflected and polarized in a manner unseen from any comet, solar system-born or interstellar. To really appreciate the magnitude of this finding, it helps to imagine light not just as illumination, but as a ripple in the very fabric of the universe, a dance of electric and magnetic fields oscillating together. When sunlight encounters dust, it scatters, and depending on the composition and geometry of that dust, its light waves can become polarized, aligned in specific directions. Polarimetry, the science of measuring this property, allows astronomers to unpick the mysteries of a comet's dust, its size, its shape, its chemistry, even hints of its birthplace. Renowned Harvard astronomer Avi Loeb, not connected to the study but deeply versed in the intricacies of light's journey through the void, offered a poetic yet precise explanation. Light is a wave consisting of a coupled oscillating electric and magnetic fields, which are orthogonal to each other in a plane that is perpendicular to the direction of propagation of the wave in vacuum. For linear polarization, these oscillations travel along a single direction. For circular polarization, they spiral with stately elegance as the wave moves through space. For comets sweeping close to the sun, that usually means a predictable dance of light, fitting neatly into patterns astronomers have documented for generations.
But 3I/Atlas did not follow this choreography. When astronomers measured the polarization of its coma, the shroud of dust and gas ignited by the sun's warmth, they found a value plunging to a minimum of negative 2.77%, with a margin of error so exquisite there could be no mistake. This deeply negative reading is dramatic, even shocking, as it means the light waves were aligning parallel to the scattering plane, with an intensity far surpassing what scientists observe in even the most exotic comets. Traditionally, comets fall into one of two polarization classes, high or low, and a few legendary outliers, like Hale-Bopp or the Interstellar Comet 2I Borisov, have occasionally hinted at more complex origins. Yet 3I/Atlas has managed to escape every box, its behavior charting an entirely new domain. As the researchers themselves captured, this polarimetric behavior is significantly different from all known comets, either interstellar or bound to our solar system. It does not fit into either the high or low polarization comet categories, nor that of the unique category occupied by just Hale-Bopp and 2I. Drawn in by the puzzle, scientists began to compare the strange light of 3I Atlas to distant residents of our celestial neighborhood, icy bodies that dwell far beyond Neptune, known as trans-Neptunian objects, or TNOs, and their kindred, the centaurs. These remnants of the solar system's formation are blanketed with ancient, untarnished ice, maintaining secrets untouched by the closeness of the sun. Startlingly, the polarization features of 3I Atlas's coma mirrored these far-flung objects far more closely than any active, sun-approaching comet. The similarities did not stop at the polarization angle. The team's in-depth analysis found that 3I Atlas's inversion angle very nearly matched that of the exceedingly rare F-type asteroids and the nuclei of comets, the dense, cold hearts left when a comet has exhausted nearly all its volatile treasures. However, there was a twist. The depth of the negative polarization was almost double that of even these reclusive bodies. At the smallest phase angles, when the comet lay nearly between the Sun and the observer, the polarization plummeted steeply, matching the profound dips seen only in specific types of TNOs and centaurs. Such a signature raises compelling questions. Does 3I Atlas, traveler from the galactic deep, share kinship with the frozen children of our own solar hinterlands? This hypothesis found further support in the color and spectrum of the comet. Other researchers analyzing the light of 3I Atlas independently detected features hinting at the presence of water ice, echoing the chemistry of outer solar system realms. The light itself was tinged redder than expected, another subtle fingerprint echoing those distant, ancient worlds beyond Neptune. As 3I Atlas drew nearer to warmth, it put on a show as old as our solar system. Volatile materials began to boil away from its surface, forming a coma luminous with a subtle green hue. But this dazzling display was short-lived. With cosmic timing, the comet faded from sight, perhaps brushed by the immense force of a coronal mass ejection, a blast of solar wind capable of dimming even a visitor from the stars. 3I Atlas melted away into the glare, unobservable for now, but leaving behind a baffling trove of data for scientists to parse and ponder.
Despite the brevity of its visit, astronomers have managed to squeeze incredible detail from fleeting glimpses. Imagery confirmed the presence of a diffuse coma, a fog of icy dust wafting from the nucleus. Yet, for all their effort, no one has yet resolved any strong polarimetric features in the coma itself. That makes what has been captured all the more extraordinary and all the more tantalizing, a strange new kind of comet, or perhaps a new class of interstellar interlopers entirely. Astonishingly, the research team concluded that these findings may demonstrate that 3I represents a distinct type of comet, expanding the diversity of known interstellar bodies. With this one visitor, the catalog of cosmic residents must now expand, an exhilarating reminder of how our understanding of the universe is anything but complete. As anticipation builds for the next appearance of 3I/Atlas, the mysteries that surround it only deepen. Astronomers around the world are tuning their instruments, adjusting their calculations, and preparing for the comet's elusive return. What new secrets might it reveal when it next slips from the dusk? Will its spectral fingerprints hold? Could its connection to far-off icy worlds be confirmed, bridging the gap between interstellar odysseys and our own cosmic backyard? In the grand theater of the universe, these questions are not mere curiosities. They point us toward the uncharted boundaries of knowledge and to the ever-shifting frontier between what we know and what awaits discovery. 3I/Atlas reminds us that our solar system is not a solitary island in space, but a mere crossroads on the intergalactic highway, regularly visited and transformed by emissaries from beyond. Tonight, as you gaze upward and contemplate the vastness beyond the familiar planets and stars, remember the fleeting light of this interstellar visitor. Its mystifying polarimetric signature, its refusal to conform, heralds not an anomaly, but the dawning realization that the cosmos still holds stories stranger than we've dreamt. And so we'll wait and watch. Instruments ready, imaginations fired, yearning to witness what secrets 3I/Atlas and others like it may yet reveal. Until that next encounter, let's keep exploring together, guided by curiosity and the wonder that every new discovery brings. Because with each unexpected visitor, the universe reminds us there is still so much out there to learn. Stay curious, keep looking up, and join us as we continue this journey of cosmic discovery, one awe-inspiring revelation at a time.